All right, here's a mini video designed to review a topic that some people might find confusing. That is epsilon transitions in non-deterministic automata. So if we're in this first automaton on top, we'll start at state A. When we read in a 0, we'll move as usual from state A to state B. And then as soon as we reach state B, we'll take the epsilon transition, which we can think of as a free transition. So we will leave one live branch in state B, and we will move our second live branch to state C. So live branches after we read in that 0 and follow our epsilon edge are the branches in states B and C. Similarly, for this automaton down here, if we start in state A and read in a 0, from state B, we can take several epsilon transitions. We can go from B to C, we can go from B to D, and we can even go from D back to B, although that doesn't extend the set of states that can be live. So the live branches, after we read in that 0, are B, D, and C. If we then read in a second 0, so now we're looking at the input string 0, 0, we start from our 3 live branches. The live branch at C will die. There's no out edge on a 0. Same with the one on B. The live branch at D will follow the 0 edge, and then, as usual, follow all of the epsilon edges it can follow. So it will also, because of the branches descended from the branch that started in state D, end up in states B, C, and D after we read that second 0. Finally, in this third state, right as we start the automaton, we have epsilon edges. So as usual, we leave a state, leave a branch in A, we branch to B, we branch to C, we follow the second epsilon branch to D, and our live branches after just starting the automaton, not even reading in any characters, are A, B, C, and D. Once we read in the 0, all of these branches die because they have no outgoing edges on a 0, but our last branch moves from D to E. So live branches after reading in that 0 is just E. Now, the last thing I want to show you is a little sanity check, which is if we concatenate the edges followed by any accepting path. So here we concatenate 0 and E. We get the input string that took us there. So if we concatenate 0 epsilon here, we get 0. If we look at the branch of computation that took the path from A to B on 0, B to D on epsilon, D to D on 0, D to E on epsilon, and B to C on epsilon, and then accepted. All of that concatenated matches 0, 0, our input string. Finally, if we look at the path of computation that went from A to C, C to D, and then D to E, that is also 0, our input string. So as a sanity check, that tells you that the way we're using epsilon edges is consistent with our definition of computation on an NFA. If you concatenate the transitions you take to get from the start state to an accept state, it should match the input string. So that's all for epsilon transitions. Thanks for watching and see you in class.